Hi everyone. So there's quite a bit of information in Chapter 2 that kind of threw a few people for a loop. But that's no problem. You know, we're all trying to wrap our brains around this and get comfortable with these new concepts. And this is certainly true for folks that have never had any exposure whatsoever to databases, and you know there are a lot of them. So we're going to get into Chapter 3 that is going to talk about the enhanced ER model. So let's take a look at that. So these are the objectives. Now, I don't think I've stressed this strongly enough in the past, but every chapter has a list of objectives that are going to be focused on through the chapter, and it's important to understand all those objectives. Now, I understand that everybody wants to learn every detail of that's offered by this text, and each chapter goes well beyond the objectives, and that's that's really cool if you want to learn all that. The information is definitely there in the book and in the modules online. But just keep in mind that you are required to know and understand the objectives, so kind of keep a close hold on those. So in Chapter 3, we're going to be talking about supertypes and subtypes, and so this takes the entities that we've discussed thus far and kind of breaks them up into smaller entities or subtypes, and we'll see how that works. So effectively, the enhanced ER model takes the supertype, and I'm not sure why they have this ordered in reverse order, in my opinion. The supertype is basically a cookie cutter entity type that has some generic attributes that will apply to other details, which will later be our subtype. And the subtype is it inherits all the attributes of the supertype, and then adds on some new attributes that makes that entity unique to the other subtypes below that supertype. So one detail that I want to touch on this slide is that an instance of a subtype is also an instance of the supertype, and we'll see how this breaks down here on this next slide. So this is kind of the breakdown of the supertype up here at the top, and then the subtypes beneath. And we'll see more detail on this, but the relationship of the with the supertype also is a relationship to everything below. Whereas the relationship with the subtype is a relationship only with that subtype, and again we'll see some more detail on that here in just a sec. So this slide basically shows you how the notation is different from one modeling tool to the other, and this is Visio, I believe, and this looks different from some of the other modeling tools that's depicted in the book, and there are many others that look different from that still. Okay, so here's an example of how that supertype subtype relationship works. So you'll notice that we have an entity, a supertype called employee, and the primary key or the identifier is the employee number, and all subtypes will have the attributes employee name. Will have the attributes employee number, employee name, address, and date hired. And then below that are the subtypes, which again inherit the same attributes as the supertype, but also has attributes that are unique to that entity. For instance, the hourly employee entity type has hourly rate, and salaried employee has annual salary and stock options. I wish I had stock options. Consultant has contract number and billing rate. So I mentioned this a little earlier. It might have been a little premature, but so I mentioned that that a relationship between one entity and an entity of the supertype is also a relationship to all of these subtypes. So, for instance, you've got an entity called responsible physician that has a relationship with patient, and patient is a supertype of the subtypes outpatient and resident patient. Now, regardless of the type of patient, they're all going to need a physician. So you see that that relationship between responsible physician and patient also applies to outpatient and resident patient. Whereas the entity for bed is only has a relationship with the resident patient, because of course the outpatient is not gonna need a bed. Now, notice the relationship and the cardinality here. Now, there are many beds in a hospital, but not all beds are going to have a patient in them, or hopefully there's going to be room for more patients. So you'll notice that right there, that is optional. That means that there may be a bed, but it doesn't have to have a patient in it. However, a resident patient must have to have a bed, so that is going to be a mandatory one. So again, keep an eye on those relationships and the cardinality. So there are methods of creating these supertype to subtype relationships. There's a generalization and a specialization, and the generalization is effectively a bottom-up type of process where you have a number of entities that are closely related, and you take the common attributes of those and put them into the supertype and have the remaining subtypes below to take on that relationship. And then the specialization, you start with a pretty complex entity at the top and break that down into lower subtypes beneath that supertype. So let's take a look at how that works. Okay, so you'll see here that we have three entity types: car, truck, and motorcycle. And you'll see some of these, or all of them rather, have some common attributes such as vehicle ID, price, engine displacement, vehicle name, make, model, and so on and so forth. So we could probably break these down and create one supertype and call that vehicle, and have the same attributes, which is vehicle ID, which is going to be our primary key, and price and engine displacement and make and model. And then below we'll have the subtypes of car, which includes the number of passengers, and then truck, and then we'll probably also have a motorcycle entity out there. Oh, I'm sorry. No, no subtype for motorcycle, since it has no unique attributes. So in other words, we can include all of the motorcycle details in the vehicle entity. So let's take a look at that again. So motorcycle has vehicle ID, price, engine displacement, vehicle name, make, and model. So you'll notice that the vehicle supertype has all of those, so that that entity can contain all of the details for a motorcycle already, so it doesn't need a subtype down at the bottom. Sorry about that. And then there's also a specialization, which takes one entity and kind of breaks down the attributes that are contained in them. And now this entity is for a part, and there are two attributes in here that apply to different types of parts. The routing number only applies to manufactured parts, and this composite attribute applies to purchased parts. So let's take a look at how that breaks down. So you'll notice that we still have the part entity, which is now a supertype, and then we have two subtypes below it. The manufactured part, which has the routing number that was identified up above as only being for manufactured parts, and then we have purchased parts. Now, let's take a look at what's happening with this. If you remember from the slide above, there's a composite attribute right here that has supplier that includes the supplier ID and unit price. So what we've done here is used an associative entity to form the relationship between supplier and purchase parts, and that this associative entity kind of takes the place of that composite the composite attribute that was that we saw in the previous slide entity. So of course, with everything else that deal with databases, we always have constraints, and again, as we learned very early in the course, a constraint is nothing more than a rule that the database must follow. So here we talk about a completeness constraint, and this is effectively whether an instance of a supertype must also be a member of at least one subtype. So, and we'll see this here in just a sec. The total specialization rule indicates that it must be a member of one of those, and the partial specialization says no, it doesn't. So, and now pay very close attention to the notation on this, because you're going to need to be using this notation when you create your supertypes and subtypes. So the total specialization indicates that a patient must either be an outpatient or a resident patient. It has to be one of those. So that, of course, is total specialization. Whereas the partial specialization indicates that it can either be a car or a truck, but it doesn't have to be either. Again, like I said, it could be a motorcycle and stay right up here in the vehicle supertype. So there are also disjointness constraints that indicate whether whether an item can be a member of one or more subtypes below the supertype. So the disjoint rule says an instance of a supertype can be only one of the supertypes, whereas the overlap rule says that it can be a member of more than one subtype. So let's take a look at how that works. So the disjoint rule says that that a member of patient can either be an outpatient or a resident patient, but it can't be both. So the disjoint rule says a patient can be either an outpatient or a resident patient, but not both at the same time. And notice that there is a D in that circle to indicate the disjoint rule. And likewise, the overlap rule indicates that a part may be a manufactured part and a purchased part at the same time, but must be one or the other due to total specialization, the double line. So effectively what that means is that it can either be a manufactured part or a purchased part or both, but it has to be one of these or both. So in other words, if we go back to where was it, to this guy, this can either be a car or a truck, but it doesn't have to be either of those. It can be a motorcycle. Whereas this says that since it is a specialized a total specialization, that it has to be either a manufactured part or a purchased part. So there's also a subtype discriminator, which is an attribute inside the supertype that will determine which subtypes beneath it are going to be also going to be associated with that entity, the entity type of that supertype. So the disjoint is basically a simple attribute with alternating values to indicate the possible subtypes, and we'll take a look at that here in just a second. Whereas the overlapping is a composite attribute containing Boolean values that identify which subtype or subtypes will be included in that relationship. So this talks about the disjoint rule, and again, as I mentioned, there's an attribute within the supertype called employee type that will contain an H, an S, or a C, and that will determine the type of employee within the subtype below the supertype. However, the subtype, I'm sorry, the composite attribute contains Boolean values for the subtypes beneath it, and this will have manufactured and purchased, and if that equals a Y on either case, then those are also included in that subtype instance. And again, now since this is it has to be one or the other or both. So this is kind of this is a pretty good example of how a lot of this stuff works. Now we have a supertype called person that has a social security number, name, address, gender, and date of birth. Okay, and then we have a total specialization on this, which indicates that it must be one of the subtypes beneath. And now notice that that we have an O here, means that is overlapping, so it can be one or many of these subtypes. Now, notice below employee that this is a partial specialization, which means that it doesn't have to be. It can be just an employee, or it can be faculty or staff. So it doesn't have to, just because it's an employee doesn't mean that it has to be faculty or staff. It can be another type of employee. And you might ask, well, why would you want to have something like that? It seems like that it's accessing data from another location that's not identified in this database system. That's not necessarily true, but it's possible. Now, the database system that we're building could very well be accessing data stores that already exist, and there may be another employee entity out there that's for other employees other than faculty and staff. We're just not accessing those data sources through our database system. Now notice also that if an employee is going to be faculty or staff, that there is a disjoint rule here that means that that employee must either be faculty or staff, but it cannot be both. Now notice also under student we have a total specialization and a disjoint rule. That now the total specialization indicates that the student must either be a graduate student or an undergrad student, and the disjoint student says that it cannot be both. It must be one or the other. So keep a close eye on that and study how those work, and get your brain wrapped around it. Okay, so we're getting back into our Pine Valley Furniture Company and the database system for that. And this is done through Microsoft Visio, and we're talking about the entity clustering for our database system. And now the text indicates, of course, that as we develop a fairly large system, it can get rather complex pretty quickly, and it's difficult to capture everything on one piece of paper or what have you. So we take efforts to cluster some of these entities into associated groups, and we'll see how that works. For instance, there's a selling unit up here that clusters those two entities together for a selling unit, and then we cluster a few more entities together for customer and item sale. Now, notice that a lot of these associative entities are not included in some of these clusters unless they are contained within the relationship of those entities. So, for instance, the relationship between product and raw material is uses. So there's an associative entity between those two locations, or between those two entities rather. But since product is part of the item entity cluster and raw material is part of the material entity cluster, then that associative entity is not going to be included in either of those clusters. However, if you take a look down here at the manufacturing entity cluster, you'll see that the associative entity between work center and union employee is included in that cluster because it's part of the relationship between those two entities. So you'll notice that out of all these entities that are clustered together, we have selling unit, customer, item sale, and so on and so forth. And those entities clustered together become a diagram that's a little bit easier to read. Now, of course, this is not going to translate at all into what we see in our final database. Again, diagrams such as this are for the suits and ties, for instance, that have no idea, nor do they care how the database works. They just want the system to do what is necessary for the system to run, and for the corporation to operate. So this is the manufacturing entity cluster that comes from this entity within that the smaller EER diagram. And if you look at this is the manufacturing entity cluster that comes from the entire diagram, and that's effectively what we have right down here. Now, of course, there are tons and tons of packaged data models. In fact, most organizations use packaged data models that are geared specifically toward their industry. They're also universal data models like a CMS database and things like that. But the amount of money that data modelers make to design a database specific to a specific organization or specific industry, they're really proud of their work, and they're also proud of their products, and the cost definitely reflects that. So this basically talks about some advantages of using packaged data models, and granted, I mean there are definitely a lot of advantages, mainly because these data models have been tested and are very true, and then it's just a matter of getting someone that knows how to manipulate those data models and or the packaged data models and kind of mold them into that. Into a model that is needed for that business. There's a lot of money that can be saved, and certainly time. And the reduction in modeling and coding errors is reduced greatly. So those are definitely a lot of advantages on those package data models. However, it's also really important to understand how all that stuff is happening behind the scenes, and that's kind of what we've been covering up to this point. Um, that's all I have for this week. Now, again, there's a lot more information in this chapter. I highly encourage that you read the chapter and read it early in the week. So if you have any questions, you can let me know, and we can get those addressed before Sunday afternoon. All right, thanks a lot, and good luck this week.